Hello there, Calcsters. Wanted to bring to you a little review of the material we were working on before spring break. We're scratching the preview on this one. I just want your brains thinking about all of the great work that you were doing before spring break, so we're ready to hit the ground running when we get back on Monday, and I'll be so excited to see you then. Let's start by taking a look at 4 of the main things that we focused on, which include the chain rule, the product rule, the quotient rule, and trig derivatives. So remember, the chain rule is such that if you start with a function that is a composite function, so a function embedded inside another function, then we can find the derivative by taking the derivative of the outside, leaving the inside the same, and then multiplying by the derivative of the inside. Okay, and we did this with a lot of different examples. Let's do one that has a trig function. So let's say we have 5 sine cubed of 2x. Now, if you remember, this one will need a rewrite because it's a trig function raised to a power. Once I have the rewrite, I'm going to go ahead and write down my levels. My outside would be 5, and I don't know, I need to write a 3 there. 5 times the quantity to the 3rd power. The middle would be the sine function, and the inside would be 2x. We then take the derivative of each piece. So we bring the power down, go to 1 less power. Whatever starts in brackets goes right back in. Taking the derivative of sine, that's cosine. Whatever starts in parentheses stays in parentheses. And the derivative of 2x is 2. We get our final answer by multiplying these 3 pieces together using one numeric coefficient. So that would be 30 sine squared of 2x cosine of 2x. Now, a few things to point out. Right here, the order doesn't matter. I could have done the cosine of 2x first and then the sine squared of 2x. Something else to note, you could have alternatively written this like so. I just prefer to do it bringing the power back inside. Now, looking at the product rule. Now, they look similar, but the difference between the chain rule and the product rule, the chain rule is one function with multiple levels. The product rule is when we have 2 functions being multiplied. So we can write it like so, or f of x times g of x. And the derivative of which, y prime, is vu prime plus uv prime. So the derivative of one times the original of the other plus the opposite of those two. All right, so a quick example. Let's say we have y equals, and let me make this all a little bit smaller, give myself some room. Y equals 2x times the cosine of 3x. Well, I have 2 functions there. 2x is my first function, cosine of 3x is my second. So u would be 2x, the derivative of which is 2. V would be the cosine of 3x. This is a chain rule function. So the derivative of the outside is negative sine, inside stays the same, and the derivative of the inside is 3. I then get my final answer by doing vu prime, so 2 cosine of 3x plus uv prime. That would give me negative 6 when I multiply 2 and negative 3. The x would come next, and then the sine of 3x. Notice in this case, I could change this instead of plus and negative. I could just do minus if I wanted to, but that's kind of a personal preference. All right, so we've talked about the chain rule. We've talked about the product rule. Let's look at the quotient rule. We use the quotient rule when we have 2 separate functions being divided. So here's 2 different ways of looking at it. The derivative of which is vu prime. Notice the same order as the product rule, but this time we subtract instead of adding, and then we divide by the original denominator squared. So let's look at an example of this. Let's say we start with the function y equals x cubed over the tangent of 5x. So I need to label. My numerator is u, my denominator is v. The derivative of x cubed is 3x squared. The derivative of the tangent of 5x. Now this is a chain rule. The derivative of the outside, which would be tangent, is secant squared. Inside stays the same. The derivative of the inside is 5. Now, putting that back together using the quotient rule, y prime is vu prime, so that's 3x squared tangent of 5x minus 5x cubed secant squared of 5x all over the original denominator squared, which I could write as the tangent of 5x squared, or alternatively, I could bring that 2 inside and write it as so. Now, you'll notice on the product rule and on this one, I haven't simplified yet by factoring. This one doesn't need to be simplified because nothing's going to cancel with the denominator, and it's really not going to simplify all that much. All right, now if you were to have factored out an x squared on top, that's great, but in this case, not necessary. Now, finally, with our trig derivatives, remember that we added on. So far, before this, we had worked on the derivative of sine and cosine. Now we added the tangent, the cosecant, the secant, and the cotangent. Now, I've asked you to write those down. It's not something you necessarily need to memorize, but the better you know them, the easier this will be for you. So let's look at one or two examples of that. Let's say we have y equals the cosecant of x squared, and we want to take the derivative. Now, a couple things you need to know. One, this is a chain rule. So we've got an outside and an inside. And in order to do this, we need to know what the derivative of cosecant is. The derivative of cosecant is negative cosecant cotangent. Now, when we take the derivative, the inside stays the same on both. So notice I have negative cosecant x squared and cotangent of x squared. The derivative of x squared is 2x. So my final answer would be negative 2x, which I get by multiplying those two together, and the cosecant of x squared, cotangent of x squared. Also remembering that the order of the cosecant and the cotangent is interchangeable. These could be flip-flopped, and that would be 100% correct. Now, after this, we focused on sinusoidal application problems. So we're talking about the mermaid jumping in and out of the water, okay, or the penguin sliding down and up and down on a slippery slope. Okay, we're going to focus on reviewing that and continuing to practice that on Monday, so I'm not going to spend time on that right now. And then we're also going to be looking at continuity and differentiability. So thank you for watching this, and I look forward to seeing you on Monday.